Welcome, and thank you for joining this webinar, Wireless Driving the Automotive Machine to Platform Transformation Executive Summary, prepared by Albert Research Team. Today, we're exploring one of the most profound shifts happening in the automotive world, the transformation of vehicles from mechanical machines into intelligent, software-defined platforms powered by wireless technologies.
Let's look ahead now towards 2030 and beyond. What's on the horizon after 5G? You mentioned 6G.
Right, the next big evolution is 6G, often referred to technically as IMT 2030. We're expecting the first commercial systems to start appearing around the 2030 timeframe. The key technology enabler here is likely moving into even higher frequencies, like Terahertz, T-Hertz communication.
Terahertz. What does that enable that 5G can't do?
Primarily, even more massive bandwidth and potentially even lower latency. We're talking orders of magnitude more capacity than 5G. This kind of throughput is seen as necessary for the truly data-intensive applications of the future, like full level 5 autonomy, where vehicles might be sharing incredibly rich sensor data in real time, or enabling those highly immersive in-car experiences.
Like the vehicular holograms you hinted at earlier.
Exactly. Things like holographic dashboards, providing augmented reality navigation overlays, or passengers engaging in high-fidelity virtual or mixed reality experiences. T-Hertz bandwidth combined with the targeted 100 microsecond air latency of 6G could make those kinds of applications feasible. And critically, 6G is expected to fully realize that concept of integrated sensing and communication, IS, that we touched on.
Right, where the network itself helps the car perceive its environment.
Yes. Instead of just being a beta pipe, the 6G network could actively participate in sensing. Imagine base stations helping vehicles build detailed, real-time maps of their surroundings, detecting pedestrians or obstacles, even in bad weather where cameras or LiDAR might struggle. This joint communication and sensing capability could provide a powerful, redundant layer of awareness for autonomous systems, making them significantly more robust and reliable.
So the network becomes an active part of the car's sensory system. That's the future of the signal. What about the future of the data being generated? You mentioned digital twins.
The digital twin concept is becoming increasingly important. Essentially, it's a dynamic, virtual replica of a physical vehicle living in the cloud. And wireless connectivity is what makes it possible, because the real vehicle is constantly streaming back that telemetry data, its operational status, sensor readings, diagnostic codes. This data feed keeps the virtual twin perfectly synchronized with the physical car.
What's the real value in having this constantly updated virtual copy?
It creates an incredibly powerful feedback loop for optimization and maintenance. Manufacturers can use the digital twin to simulate how a new software update might perform on that specific vehicle before deploying it. They can analyze performance data across thousands of twins to identify systemic issues or areas for improvement. And for maintenance, by spotting tiny anomalies or deviations in the twin's data stream compared to its expected behavior, they can predict failures long before they happen and schedule proactive service. It allows continuous learning and improvement throughout the vehicle's entire life cycle.
A continuous virtual test bed for every car on the road.
Dynamic wireless power transfer, DWPT, is the ultimate goal for many. Instead of just charging while parked, imagine vehicles charging wirelessly while driving down dedicated lanes on highways or even city streets. Standards bodies, like SAE with J29543, are actively working on making this technically feasible and standardized.
What would be the main benefit of charging on the move?
The implications could be revolutionary, primarily for battery size. If a vehicle can replenish its charge frequently while driving, it may not need a massive, heavy, expensive battery pack designed for 300 or 400 miles of range. Some studies suggest dynamic charging could allow for significantly smaller batteries, potentially reducing size by up to 90% in some theoretical scenarios, because the car only needs enough energy to get to the next charging segment. This would drastically reduce vehicle cost, weight, and resource consumption.
That would be a game changer for EV adoption. And dynamic charging also enables vehicle-to-grid.
Absolutely. Future wireless charging systems, both stationary and dynamic, are expected to be bidirectional. This means the vehicle can not only draw power from the grid, but also send power back to the grid when needed, perhaps during peak demand times or to help stabilize frequency. This is vehicle-to-grid, or V2G. It effectively turns the entire fleet of connected EVs into a massive, distributed energy storage resource, helping to balance renewable energy generation and improve overall grid resilience. The car becomes not just a mode of transport, but an active participant in the energy ecosystem.
So, from enabling software updates to potentially reshaping our energy infrastructure, it's clear that wireless connectivity is far more than just an add-on feature now. We've covered a huge amount of ground: the market forces, the diverse technology toolkit from 5G to UWA, the practical applications like OTA and digital keys, the factory transformation, the very real challenges around security and reliability, and this exciting future outlook.
So what does this all mean? The message is clear. Wireless is no longer an add-on. It is the infrastructure of modern automotive value. If you take away one thing from this review, let it be this. Wireless is now the central nervous system of the automotive industry, and mastering it is essential to driving the future of mobility. Interested in gaining a deeper understanding of the transformative power of wireless technology? Join the Alpert research team's webinars to explore cutting-edge wireless innovations, their applications, and their implications. Click the links below to learn more.